So today we will be discussing about the comparison of the instructions which are used in 8085. As we have seen that in 8085 we have a lot of instructions. 74 types of instructions are used, and every instruction is meant for uh, its own purpose. Besides that, there are certain instructions which seems to be similar, which are doing similar kind of operation, but the resultant of these instructions are a little bit different. So with this, we want to make clear about the working of the individual instructions. So the first instruction which is to be compared is the difference between the subtract A instruction and move A00. Now, before we go into the detail that how this instruction works, first of all, what is the meaning of subtracting A and what is the meaning of MVI A00? Let us understand this first. When we say subtract A, it means we want the content of accumulator to be subtracted from the content of accumulator. So if we are doing this kind of operation in which we are subtracting the content of accumulator with accumulator itself, it means we want to make the resultant as 0, because if you subtract a number from itself, the result will be 0. And the result will be stored in the accumulator itself. And the second instruction is MVI A00H. And the purpose of this instruction is to load the 00 content into the accumulator. So the resultant is going to be same whenever you do SUBA instruction. And if you do MVI A00, the resultant which will be stored in the accumulator, that will be 00. But there is a difference. The first difference lies in the addressing modes. Subtract A represents register addressing mode. Besides, MVI A00 represents a data transfer mode. Now, subtract A comes under the category of arithmetic instruction. MVIA comes under the category of data transfer instruction. The number of bytes which will be consumed in subtract A is 1 byte instruction. And MVI A00 is a 2 byte instruction. So there are a lot of difference. Besides that, the working of these two instructions are also different. Subtract A, the first parameter on which these two instructions are compared is the number of instruction bytes. Subtract A is a 1 byte instruction and MVI A00 is a 2 byte instruction. Meaning thereby, for storing this instruction in the memory, it requires only one memory location. And for storing this instruction MVI A00 in the memory, it requires 2 memory locations. As far as the operations are concerned, subtract A is going to subtract the content of accumulator to itself, because we know whenever we do arithmetic operation or the logical operation, the reference is accumulator. So if I am writing SUBA, it means content of accumulator is subtracted from the content of accumulator and the result is stored in the accumulator. What about MVI A00? It is going to load 00 in the accumulator. So this is the difference in between these two. Third one is the addressing mode. As I told you that it is a register addressing mode, and this is immediate addressing mode. Now, the flag conditions. What will happen if we go through the register addressing mode, means subtract A. Since it is an arithmetic instruction, and as you know that while executing any arithmetic or the logical instructions, all flags are going to be affected. So that is why it is written, this instruction affects all the flags: sign flag, zero flag, parity flag, as well as the carry flag. All flags are going to be affected. And MVIA 00, since it is a data transfer instruction, so it is not going to affect any kind of the flag. That is the main difference between the subtract A and MVIA. The resultant of both the instructions are 00 will be placed in the accumulator. But due to subtract A, flags are being affected. But MVIA 00, it is not going to affect any kind of flag. Now the T state required to execute. Subtract A is a single byte instruction. So there will be one operation, machine cycle operation, that is called memory fetch. And it will be taking 4 T states. And MVIA 00 contains two machine cycle. One will be opcode fetch and second one will be the memory read. So it will be taking the memory fetch operation, opcode fetch operation will take 4 T state, plus memory read operation will take 3 T state. So total it is 7 T state. So the machine cycle required is first only one, that is opcode fetch, and it requires two machine cycle. One is opcode fetch and second one is memory read operation. So this is the difference between subtract A and MVIA 00. Let us move on the second. Subtract B and compare B. Subtract B and compare B. Subtract B is going to subtract the content of B register from the content of accumulator, and the result will be stored in accumulator. And compare B is going to compare the content of B register with the content of accumulator. But it is not going to change the resultant into the accumulator. Only comparison is being done. Of course, subtraction operation is performed for comparing content of accumulator with content of B register. But the resultant of the subtraction is not stored in accumulator, meaning thereby source register and the destination register remains as it is. It is not going to change. But whenever we do subtract B, B is subtracted from the content of A. So content of A is going to change. But in case of compare B, content of A is not going to change. Both the instructions are doing some kind of subtraction process, but subtraction B is going to affect the destination, that is accumulator, and compare B is not going to affect the destination register. Both the instructions, now first parameter in which it is compared, it is the number of instruction byte. Subtract B is a 1 byte instruction. Compare B is also 1 byte instruction. So both are same as far as the number of instruction bytes are concerned. The second one is the operation. What kind of operation is being performed? Subtract B is going to subtract the content of register B from the accumulator, and it is going to store the result in the accumulator. But compare B, subtract the content of register B from accumulator, and it is going to affect all flags according to the content of register A and B. Meaning thereby, if the content of A is greater, 0 flag will reset and carry flag will reset. If the content of A is less than content of B, carry flag is going to set. 0 flag is going to reset. If the content of A is equal to the content of B, 0 flag is going to set and carry flag is going to reset. So with this operation, all flags are affected. Sorry, the content of B is subtracted from A and result is stored in accumulator. But in this case, only flags are affected. Content of A is not altered. The result is the another parameter. Result of A minus B is stored in A. The result of A minus B is not stored in A. So the register A remains unchanged. Suppose register A contains 5, register B contains 3. So 5 minus 3, if we do subtract B, 2 will be stored in accumulator. But whenever we do compare B, 2 will not be stored in accumulator. Accumulator, if it is having 5, it will remain 5. Flags. This instruction is going to affect all the flags. And this instruction is also going to affect all the flags. This instruction is taking 40 since it is a 1 byte instruction. So only 40 state. This is also 1 byte instruction. It is also taking 40 states. And the machine cycle which is required for subtract B and compare B is also same. That is opcode fetch. That's all. And both the instructions belongs to the category of addressing mode, that is the register addressing mode, because the register is used to signify the address of the data. What you know, the addressing mode? Addressing mode is a kind, the way operand is defined, where the operand is. If it is defined immediately within the instruction, that is called immediate addressing mode. If it is defined by the name of the register, it is called register addressing mode. If it is defined by assigning the address of the memory location, it is called direct addressing. If it is defined by an address which is stored in a register pair, that is called indirect addressing. So both belongs to the register addressing. So it means subtract B and compare B seems to be same, but the difference lies where that after doing subtract B, content of accumulator is going to change, but after comparing B, content of accumulator is not changed. Of course, this instruction is going to affect, both the instructions are going to affect all the flags. And depending upon the flag condition, we can take the decision. The programmer or the user can take the decision. So this is the second instruction which is being compared. Third, compare instruction LXIH2000H and LHLD2000H. This LXIH200 is going to load 2000 in HL pair. But LHLD instruction is going to load the HL pair by the content of the memory location, which is signified by 2000 and 2001. So it means LXIH instruction is going to load the 16-bit number in the HL pair directly, immediately. And LHLD is going to store the content of 2000 memory location into L register and content of 2001 in H register. So this is a 3-byte instruction. This is also a 3-byte instruction. Why? Because in this, along with the opcode, along with the mnemonics code, along with the opcode of LXIH, you have to feed the 16-bit number. In this case also, LHLD will have its own code and you have to feed along with the 2000, that is 16-bit. So 8-bit plus 16-bit, 24-bit, 8-bit plus 16-bit, 24-bit. So both the instructions are 3-byte instructions. This instruction is going to load 2000 itself in the HL pair. But this is not going to load 2000 in HL pair. This instruction loads the content of 2000H memory location into L register and content of 2001 memory location in H register. Now, Both the instructions are working, seems to be similar, but they have different operations. And as far as the addressing modes are concerned, this instruction LXIH belongs to immediate addressing because you have to supply the data immediately. And this is a direct addressing mode in which the address is defined directly within the instruction. So the meaning of 2000 and meaning of this 2000 is different in both the instructions. Here, in case of LXI, 2000 is considered 2000 is considered to be the data, 16-bit data. Here 2000 is considered as 16-bit address of the memory. Since both the instructions belongs to data transfer instruction category, so no flags are going to be affected because we know that while executing any data transfer instruction, it is not going to affect any kind of flags. It is only the arithmetic or the logic instruction due to which the flags are being affected. Flags remain unaffected by using any kind of data transfer instruction. So this instruction does not affect any flag. And this instruction also does not affect any flag. Now, this instruction takes 10 T states. Why? Because one will be opcode fetch, which will be 4 T state, then memory read to read 00, that is 3 T state, and then again memory read, that is 20, it is also 3 T state. So 4 plus 3 plus 3 equal to 10 T states. But in this case, LHLD 2000, it will be taking 16 T states. Why it is taking 16 T states? Because one will be the opcode fetch in which it will be fetching the opcode of LHLD and trying to understand that what it has to do. And once the decoded instruction is fetched and decoded, opcode is fetched and decoded, which will be taking 4 T state. The second operation will be the memory read operation to read the lower byte of the address, then to read the upper byte of the address. So opcode fetch, memory read, and memory read has been done in accessing LHLD and 2000. Once LHLD 2000 has been accessed, then what it has to do? Again, it has to go to the memory location 2000, and whatever data is written at memory location 2000 will be copied in the L register, and that will again be the memory read operation. And then again it will be going to read the content of 2001. So again it will be fetching the memory, it's going to read the memory. So again we have a memory read operation. So we have 4 plus 3 plus 3 plus 3 plus 3. 3 4s are 12 plus 4. Total 16 T states, 5 machine cycles and 16 T states. In this 3 machine cycle and 10 T states. One thing you have to be very clear, if there is an opcode fetch operation as a machine cycle, it will take 4 T state. And if it is a memory read or memory write operation, it will take only 3 T state. So in this way, we are able to compare LXIH instruction and LHLD 2000 instruction. Then we have another instruction which is to be compared, that is jump 2000. This is unconditional jump instruction, branching instruction. And this one is PCHL. It is going to copy the content of HL pair into the program counter. And it is going to jump from the memory location, whatever it is executing, to the 2000. So this instruction is a 3-byte instruction, that is jump 2000, 3-byte instruction, 1 byte for the opcode and 2 bytes for the memory read. 00 and 20. And PCHL is a 1 byte instruction. So what this instruction is going to do, that is jump 2000. This instruction is going to load 2000 H in program counter, and the microprocessor is going to fetch the next instruction from the memory address, that is 2000. Meaning thereby, since it has to execute, whenever it is being executed jump 2000, after execution of jump 2000 instruction, it will jump to memory location at 2000, and from 2000 it will start execution. But PCHL instruction does another thing. This instruction is going to copy the content of HL pair into the program counter. So the processor is going to fetch the next instruction from the address which is specified in the HL pair. So both the instructions are working similarly. In this, 2000 is loaded in the program counter. In this, content of HL pair is loaded into the program counter. But the difference is that in this case, you know what is the address where it has to jump. In this case, you don't know the address, but you know that the address is residing in the HL pair. So that is the difference in between these two instructions. Both the instructions are loading the address value into the program counter. This is loading 2000 and this is loading whatever is content of HL pair into the program counter. So addressing modes, this is direct addressing mode because the address is defined directly within the instruction. But this is indirect addressing because we don't define the address, but we define the location of the address. So we are saying that HL pair contains the address, but we are not defining the address because we don't know what is the content of HL pair. So this is why, that is why it is the indirect addressing. Now both the instructions belong to the data transfer. So both the instructions are not going to affect any kind of flag. It is not going to affect the flag. It is also not going to affect the flag. Now number of T state required. If this instruction is being used, jump. So it will be 3 memory locations will be used for storing that number. And what will be that? It will be opcode fetch, which will be taking 4 T state, memory read for reading the lower byte address, and memory read for the reading the higher byte address. So it will be taking 3 machine cycles. But this PCHL is a single byte instruction and there is only 1 machine cycle in that. And this one machine cycle is going to take 6 T states. In 4 T state will be consumed in the normal operation. That is, address is being sent on the address bus. ALE signal goes high in the first T state. Second T state, read signal goes, and ALE signal goes low. Read signal is going to low, and input output memory signal is going to become low. And in the fourth T state, whatever is the content of PCHL, that is the opcode of PCHL, will be fetched, decoded, and executed. So 4 T state will be required to execute PCHL. But once PCHL has been decoded and 4 T states are over, what it has to do, it has to copy the content of HL pair into the program counter. So next 2 T state will copy first the content of L register into the lower byte of program counter, and then 6 T state will be copying the content of H register into the higher bytes of the program counter. So in this way, these two instructions used to work. The next one is the comparison between halt instruction and no operation. Both the instructions are used to stop the processing. But the difference between halt and no operation, as explained earlier also, halt means permanently stop and no operation means temporary stop. NOP stands for no operation. HLT stands for halt. Halt means to stop permanently, don't proceed. But no operation is meant for temporarily stop, temporarily halt, and then it can resume. Both the instructions are single byte instruction, 1 byte. This instruction HLT is going to halt the processor and no further execution is possible after writing HLT. But in case of no operation, when the no operation is performed, 00 is its opcode. Whenever this no operation is performed, the microprocessor is going to stop for 40 states only. It consumes 40 state, and after 40 state, it starts execution of the next instruction, which is written just after the NOP instruction. Condition of the flags. This instruction is not going to affect any flag, and this instruction is also not going to affect flag because both the instructions are machine control instructions. T state required. T state required is undefined because this instruction halts the processor, and the processor can be restarted by a valid interrupt signal or by applying the reset signal. But in case of NOP, that is no operation, it also consumes 40 states. It consumes 40 states, and after 40 state, this processor fetches the next instruction, which is written just after the no operation instruction. So that is the difference between the halt instruction and no operation. Then we have to compare the instruction, compare in between call, return, and push and pop. Call, return instructions are used for subroutine purpose, and push pop instruction is used for stack operations. So that is what has been written. These instructions are used for the execution of the subroutine because call is the part of main program and return is a part of subprogram. And push and pop instructions are used to store and retrieve the content temporarily, data temporarily into the memory location, which is used to store the data in a certain fashion, that is last in first out or first in last out fashion. As far as the call instruction is concerned, call instruction is going to store the address of the next memory, next instruction, which is written after the call instruction into the stack and going to load the program counter with the address given with the instruction. So whenever we use call instruction, call is followed by a 16-bit address, and that address defines the address of the memory location where the subprogram is written. And then whenever it returns, it requires where it has to return. So the address of the memory just after the call instruction, whatever will be there, which is already incremented by 1 in the program counter, that program counter is saved in the stack. So content of program counter is saved in the stack, and it is being done automatically. No need to use push and pop operation while using the call instruction. It is being done by the call instruction itself. Push instruction stores the content of the register into this stack. Third, return instruction is going to load the address which is placed in the stack back to the program counter, and pop instruction is used to retrieve the content of the stack back to the register. So this is the difference between these three instructions, but they have similarities also. The first similarity is they use stack memory. In this case, they use a stack to store the program counter content. In this, they use to store the content of the register pair. Call and push instruction is going to decrement the stack pointer by 2, both instruction, because whenever we are using call instruction, the program counter content will be used to store in the stack. So stack pointer will be decremented by 2. And push instruction is also going to decrement the content of the stack pointer by 2. Return and pop instruction increments the stack pointer by 2 with a similar operation. And both the instructions are not going to affect any flag except if we are using pop PSW. This pop PSW is going to affect the flag, because in that case, we are trying to retrieve the content of the stack into the program status word, that is the combination of accumulator as well as the flag register. Besides pop PSW, both the instructions are same and not going to affect any flag. Only pop PSW is going to affect the flag. That is all as far as the comparison of the instructions are concerned.